Hello again, guys. Today we're going to take a look at prime factorization. Now, this is something that we did last year in 6th grade, so this should be a bit of a review, but again, if you need to slow it down and watch it again, feel free to. So let's just do some vocab here since we're talking about prime factorization. First, let's review what is a prime number. If you'll recall, a prime number is a whole number that has only two factors, 1 and itself, and it has to be greater than 1. If you'll recall, 0 and 1 are neither prime nor composite numbers. A composite number is a number that has more than two factors. There's more than 1 in itself that will go into it. And so prime factorization is simply a way to break down a larger number into its prime factors, meaning what are the prime numbers I can multiply together to get this composite number. So that's what prime factorization is. I briefly want to review your divisibility rules. This is, again, something that you should know and you should remember. We've done this before, but I will review them with you. So these are just quick rules to help us when we're doing this so we know a number is divisible by one of these numbers. If a number is even, it's divisible by 2, meaning it ends in a 0, 2, 4, 6, or an 8. For 3s, you add up the digits of the number. For example, 69, you add your 6 and your 9 together. You would get 15. 15 is divisible by 3, so 69 would be divisible by 3. So add up the digits that make up that number. If they're divisible, if that number is divisible by 3, the number is. 4, if the last two digits are divisible by 4, the whole number is divisible by 4. 5, if it ends in a 0 or a 5. 6, it needs to be divisible by both 2 and 3. If 2 and 3 go into it, 6 will as well. 8 is if the last three digits are divisible by 8, then your number is divisible by 8. Sorry, I erased a few of those words there. I'll write those back up there. And remember, I know there's a lot of writing, so feel free to pause the video so that you can get it all down. 9 is very similar to 3. If the sum of the digits are divisible by 9, that means the number is divisible by 9. And 10, the last one, if it ends in a 0, it's divisible by 10. So those are your rules. You should be familiar with them. So how are we going to come up with the prime factorization? We're going to use a factor tree. So you'll notice I've drawn a lovely tree over here. And I circle my prime numbers, and I make monkeys, primates, prime numbers. Kind of helps you remember how it is that monkeys swing in trees. Just a little visual to kind of help you remember what you're doing. So how do we make a factor tree? Well, we start out with a big number. So I started out with 160 here. So I want to come up with factors that go into 160. Well, the first thing I notice ends in 0, so that means it's divisible by 10. So 10 will go into it 16 times. So 10 times 16 gives me my 160. So I'm breaking it down into its factors. Neither of those are prime, so I need to keep going. 10 I know is divisible by 5 because anything that ends in a 0 or 5 is. So 5 times 2 gives me 10. 5 and 2 are both prime numbers, which is why I've circled them, or in this case made primates, monkeys, out of them. So I'm going to circle them. I know that I'm done on this branch. This branch is complete. It's down to its prime numbers. I look at 16. It's even, so I know that 2 goes into it. 2 goes into it 8 times. I circled 2 because it's prime. 8 is not. 2 goes into 8 because it's even. 2 times 4, again, 2 is prime. 4 is not. So I break 4 down into the 2's and I circle them. So that's the factor tree. Then what we want to do is we want to write it in its exponential form. So what I want to do is I want to count up how many prime numbers I have of each number. So let's start with the 2's, and we're going to write it in exponential form. So 2 is my base. How many 2's do I have? 1, 2, 3, 4, 5. 2 to the 5th times, and I only have one 5, so I'm just going to write my 5, times 5. This is the way that we would write the prime factorization in exponential form. So count up how many you have. How many of each number, that's your exponent, and then we write it as if it were a multiplication problem. So basically the prime factorization, what I'm saying is these are the prime numbers I can multiply that'll give me 160. And if you go through and you do this multiplication 2 to the 5th and then multiply by 5, you'll find that you get 160. All right, so then I just wanted to try a couple of examples here to practice our factor trees. So I draw my branches. The first thing I notice, it ends in 0, so that means 5 will go into it. It also means 10 could. And what you'll notice is you can pick different numbers. You'll still wind up with the same result. So I could start with 5 and 6 here, or I could start with 10 and 3. I'm still going to wind up with the same numbers. It doesn't matter. Eventually I'll get down to my prime numbers. So the numbers you pick aren't important as long as they're factors and they come out evenly. So I know 5 goes into here. That's prime. I'm going to circle it. It goes in 6 times. 6 is not prime, so I need to keep going. 6, I know that 2 will go into it. And 3, those are both prime numbers. Now if I want to write this, I'm going to write it as a product of my factors. So 2 times 3 times 5. And what you'll notice is I put them in numerical order. You want to start with a low number and work your way up instead of just randomly writing them the way I have up here. Here I have 5, 2, 3. We want them to go in numerical order. So just look and start with your lowest number, work your way up, write it as multiplication. If I multiply 2 times 3 times 5, I'm going to wind up with 30. So we've worked backwards to get the prime factorization. All right, 80. Let's do 10. 10 goes into it because it ends in a 0. 10 goes into it 8 times. Neither of these are prime numbers, so I need to keep going. 10 is divisible by 2 because it's an even number. 2 times 5. These are both prime, so I'm going to circle them. 8 is 2 times 4. 2 is prime, 4 is not, so we're going to keep going. 4 breaks down into 2 times 2. So again, I'm going to start with my lowest number, 2. How many 2's do I have? 1, 2, 3, 4. 2 to the 4th. I have 1, 5. 2 to the 4th times 5 is the prime factorization of 80. And again, if you want to, you can pause, you can go back, and you can do these using different numbers, and you'll find you still wind up with the same thing. All right, 2 more that we'll do here, making our factor tree. Here I have 63. If I add up the digits of 63, I get 9, which means this is divisible by both 9 and 3. So I'll put 9 up here. 9 goes into 63 7 times. 7 is a prime number, so I'm going to circle it. 9 is not. 9 is divisible by 3. 3 times 3. My 3's are prime, so I'm going to circle them. Then we're going to write our answer out. This is the work that we're doing to get to our prime factorization. The answer is when I write my my numbers here as a multiplication problem. So I have I have 2 3's, or 3 squared, 3 to the 2nd power, and I have 1 7. So 3 squared times 7 is the prime factorization of 63. All right, if we look at 52, I notice it's an even number, so I know 2 will go into it. I'm going to circle my 2 because that's a prime number. 2 goes into it 26 times. 26 is an even number, so I know 2 will go into it. 2 will go into it 13 times. Circle my 2. 13 is also a prime number, so I'm done because there's nothing left to factor. I'm down to my prime numbers. I have 2 2's and 1 13. 2 squared times 13. Get out of the way so you can see those. If you have any questions on this, feel free to rewatch the video. Also, you can post them in the comment section. You can email me. I'll get to them in class tomorrow. Have a great night, and I'll see you guys tomorrow.